Now, good morning, friends. We are having a sequencing problem. Earlier, we have taken the problem on here. If you go, it is n jobs through two machines. So this problem is also n jobs from A to I. There are more than two jobs here, A from A to I, but the machines on which these jobs are performing is only two. The difference between the earlier problem, what we have seen, and this problem is that in this problem, what we have taken earlier, so the processing times, so they are unique. So no processing time is repeated anywhere here. But the problem what we are taking now. So here if you take for example, so if you take 4 the processing time, here also I have one more 4 here. So one more 4 here. So there is a tie or clash on the processing time. Let us see how to overcome this situation. Now, as usual, take the smallest processing time. So, in the given table, so that is 2. So, this 2 is not getting repeated in any other rows or columns here. So, this is unique value. So, this is on first machine and that is for the job A. Since it is on the first machine, so job A to be sequenced in the beginning. So we are sequencing job A in the beginning. So the next minimum processing time is 3. So that is on machine 2 for the two jobs E and G. So here we have the two jobs E and G. We have the tie between this 3 and this 3. So what we have to do in this type of situation. Now you take the corresponding processing time on machine 1 for these two values of 3. So that is go for machine 1 now. So the corresponding processing times are 6 and 7 on machine 1 for the jobs E and G here. So that is E and G. Sorry. So, if the processing time is more for the first machine, so it has to be sequenced in the last. If it is less for machine 1, it has to be sequenced in the beginning. So, these E and G should be kept in the last because the tie is happening now with the machine number 2 for the smallest processing time. So the smallest processing time on machine 2 to be sequenced in the end. So that means the corresponding jobs E and G to be sequenced in the end. But which one should be kept in the end, whether E will come in the end or G will be coming in the end. So that is the question. So now you have to see for the processing times for E and G here. So E is consuming 6 hours on machine 1 and G is consuming 7 hours on machine 1. So on machine 1, the one which consumes less time will be done first and one which consumes more time will be kept in the end. So accordingly, so G will be kept in the end, then E will be following that. So that is what we have written here. Now, uh, uh, now the minimum processing time so is 4. So that is for 3 jobs now, C, I and D here. So we have C 4 hours, so D 4 hours, so then I, so that is also 4 hours. So there is a tie uh, on these three jobs. So that is CD and I, and as well as it is on both the machines. So now for C and D, so it is the tie is happening on machine 1 and D, it is on machine 2 now. So take the corresponding time for C and I. So that is the tie is occurring here. So on the first machine, so that is C and I. So take the corresponding time. So that is 7 and 11 for these job C and I on machine 2, 7 and 11. So that is 7 and 11. So we have here, so that is, so place I first and C next to it. So that is here, if it is for the second machine, so we are taking here 7 and 11. If it is more on machine 2, so that has to be sequenced in the first, and the one which is taking less time to be sequenced in the next. So that is C and I should come in the beginning of the sequence. Whether I should place C first and I next to it, or I first and C next to it. So that is the question. So we are considering this 7 and 11. So which is taking more time on machine 2 to be sequenced in the beginning. So that's why here I am processing I first and then C next to it. So we have A, I, C and then D, E, G.